This is a recorded lecture for Chapter 8 regarding agility development in youth populations, and this lecture is associated with PET 1696, Youth Physical and Athletic Development, which is being offered at UCF for the summer of 2019. Hi class, this is Dr. Red. We are doing a little bit different format this evening in regards to the delivery of your lecture. And we're doing that because of the way that your research discussion and a group presentation kind of fell on the same night. And I thought this would be kind of an improved way of still delivering the content information to you, but allowing for us to focus more of our class time together on your research discussions, as well as giving enough time for our first group to present. So I hope you enjoy this particular delivery of the lecture. Let's go ahead and jump right into discussion of agility development. If you remember back to Chapter 4, it outlined the importance of developing physical literacy in youth athletes, both as developing sporting excellence, but also maybe more importantly, physical activity for health reasons. And physical literacy itself is composed of fundamental movement skills together with fundamental sport skills. And one key element of fitness that's closely linked to these fundamental movement capacities is the concept of agility. And the development of agility should be included as a part of some sort of long-term physical development program for athletes. So what is agility? We understand that it's generally regarded as a key component of athletic performance, but the term agility can be very difficult in order to define, because typically agility or the expression of agility is truly dictated by the sport context in which it's expressed. And so what that means is agility can mean very different things even among the sports themselves. And to review concepts that we've previously discussed in class regarding agility, I've kind of taken some information from Chapter 4 and kind of reinserted it into this particular lecture because it's absolutely everything to do with agility. So we remember from Chapter 4 that agility is comprised of two things: these perceptual decision-making factors as well as change of direction factors. And to be even more specific, we understand that an athlete's ability to change direction is directly influenced by their technique in the sport, the athlete's individual anthropometrics, that's always a hard word for me to say, the athlete's ability to produce some sort of straight sprint speed, as well as the athlete's leg strength. And we understand that in order to assess one's agility, the assessment battery that's chosen really needs to take into account all of these factors, but even more so needs to be event or even, if possible, sports specific. A lot of times we see these talent identification processes or assessments that are chosen that are problematic simply because of the multifactorial nature of this component, especially in regards to the perceptual decision-making skills of young athletes, because of the fact that that is something that's very much developing over time as their brains mature. So it's very much influenced by age as well as experiences excuse me, of the athlete. So it goes without saying that the most change of direction factors are really influenced by the athlete's physique as well as the athlete's physical maturity. An important note for coaches and trainers to be aware of when selecting any sort of agility assessments is maybe to stay away from these generic assessments because they may not be necessarily a good predictor of a child or an athlete's true potential. This diagram, created by Damien Farrow back in 2006, does a really nice job of laying out for all of you visual learners out there. You can see the different elements that comprise of agility. So you can see that technique comes from proper foot placement, any sort of adjustments the athlete may make to their strides in order to accelerate or to decelerate or to re-accelerate, as well as things like their body lean and posture. So technique, straight sprint speed, as well as their leg muscle qualities in order to produce strength, power, reactive strength, all lead to an athlete's ability to change direction quickly as well as efficiently. And then you can see different concepts related to those decision-making factors. Athletes that can scan the field and are aware of certain situations or can maybe anticipate future patterns or plays that might develop. So that's where pattern recognition comes in, and also knowledge of certain situations. And with those combined as decision-making factors, and maybe even with a little bit more experience in the particular sport, we have that concept where decision-making factors and their change of direction will improve their skills in agility. So to kind of revisit this definition of agility, we understand that agility is a complex parameter and it involves far more than the performance of just certain movements. So agility can be viewed as game speed being context-specific movement, where an athlete maximizes their sport performance through the application of some sort of sport-specific movement of optimal velocity, precision, efficiency, as well as control in anticipation of and in response to the key perceptual stimuli and skill requirements of the game. This definition kind of provides a context for agility and really requires that a coach carefully study the agility requirements for sports and then develops these appropriately in the young athlete in order to maximize transfer that coming from training into specific sport performance. How important is agility? Do coaches need to place an emphasis on agility training in their practices with youth populations? And what we can see from the literature is that high levels of agility, or the practice and training of agility, has an ability to enhance the levels of performance of youth athletes across a wide range of sports. And so agility is an important bridge between technical training and actual performance. A lot of times, the quality of a youth's performer's skills is very closely linked to their ability to react and also to move into optimal positions in order to perform these skills. So therefore, agility could be considered as a fundamental skill required for effective performance in a range of sports, with competency in underpinning movement abilities, providing a base in which successful sports performance can be built. And this is supported by the fact that children can often perform new skills effectively because of already present and general underlying motor abilities. The development of effective movement capabilities should then be an integral part of all youth athlete development programs, and this is because underpinning athleticism and movement capacity are likely to enhance performance across all of these sports. Before we examine the trainability of agility in youth populations, it's first important to examine any key factors underpinning effective agility. Essentially, effective agility in a game context involves a perception-action cycle, and this is where an athlete would seek information from the external environment, from the sport that's being played, the game that's being played, and then processes that information in order to elicit an appropriate movement response. According to Jeffries, when the limits to expression of effective agility are really examined, he found three main constraints: organismic, task, and environmental constraints. So an organismic constraint refers to any sort of specific qualities of the individual in relation to the entire perception action cycle. Our task-based constraints involve the unique characteristics of the task itself. So what are the rules that the athlete has to abide by when they're participating in baseball, basketball, or soccer? And then environmental constraints talks about the unique characteristics of the environment where the game is being played. Many of these constraints will become of increasing importance as the level of specific sports performance increases, as well as when the youth progresses through the developmental pyramid. And if you look in your textbook, on page 109. Actually, I'll show you a picture of it as well here in a minute. You can see the foundation, the development, and the performance that's required in order to build agility, and it's called the Agility Development Pyramid. If we were to break down the organismic constraints a little bit more clearly, we would know that there are 4 of them. And so the first component of an organismic constraint is the physical constraint. So the athlete's force production capabilities, the stretch shortening cycle capabilities of the muscle, as well as maybe mobility or mobility issues that are present with the athlete. We also look at motor control, which is then the capacity to select but also use appropriate motor patterns under the pressures of playing in the game and abiding by those rules. We also look at perceptive organismic constraints, which is the ability for an athlete to pay attention, to be aware, also to detect any sort of key elements of the external environment as a ball or an object of the game that's participating in the game or part of the game is approaching them. And then we also have this cognitive organismic constraint, which is the ability of the athlete to process the information and then, based on their interpretation, make an appropriate movement choice in order to be successful, not only in the task, but also on the field or on the court, depending on the sport that they play. And so this is a good graph that kind of identifies those organismic constraints for you. And you can see here they are from left to right. We see our perceptual, our cognitive, our physical, as well as any sort of motor control constraints. An athlete's ability to develop their skills regarding agility throughout childhood, throughout adolescence, really requires a learned ability to deploy movements with consistency, efficiency, and effectiveness, of course, in a sport-specific context. Quite clearly, we understand that agility is a skill, and with most skills, they need to be developed in accordance with some sort of optimal mode of learning, as well as some sort of optimal mode of development. So it's important to really examine the natural development of agility in youth athletes and how this can be optimized through an appropriate training program. Challenge, though, to the development of an optimal model for agility is that agility kind of is one of this under-researched aspects of pediatric performance. And so this makes it difficult to really ascertain the effects of age, the effects of maturation on agility performance. And it also makes any recommendations as to the optimal training of agility very speculative. To offset this limitation, then, it's useful to categorize agility performance through the organismic constraints outlined in the previous picture that we just covered in regards to task constraints, environmental constraints, as well as organismic constraints. So examining agility under those particular banners will allow research in other domains of pediatric physical development to be examined, and then we can extrapolate those results to agility performance. Let's start by analyzing the physical constraints. Any sort of physical constraint that adds to the increased ability for an athlete to be agile should consider a couple of key factors, specifically 2. We need to consider linear running speed as well as the athlete's force-producing capabilities. In terms of force-producing capabilities, it's expected that healthy children will demonstrate noticeable gains in muscle strength during the developmental years as a result of natural maturation. We also understand that adolescent athletes make greater absolute gains than children. And so given that agility expression requires the application of force, then an associated increase in the force-producing capacity should result in a natural increase in agility performance. However, a key factor, whether this force-producing capacity can be augmented through training, is an issue. there is a compelling body of evidence that indicates that with an appropriate resistance training program, children as well as adolescents can significantly increase their strength over and above that resulting from simple growth and maturation alone. And we can see that here. Sorry, I talked before I clicked the slide over. And that research, by the way, was done by Feigenbaum in 2008. He also concluded that during and after puberty, which is something that we've heard in class before, strength gains are associated with not only neural but also hypertrophic factors. With children prior to puberty, any sort of gains that are made are predominantly neural in nature. Any sort of neural adaptations would include things like increased motor unit activation, changes in motor unit coordination, as well as recruitment and firing, as well as an associated increase in motor skill performance. Improvements have been recorded in a number of motor performance skills following resistance training, including standing long jump, vertical jump, sprint speed, and medicine ball toss. While no data currently exists as to whether agility can be improved through enhancing a youth athlete's force-producing capacity, the potential neural adaptations, as well as their subsequent effect on motor performance, does suggest the potential to increase agility performance through an enhancement of the force-producing capacity, and that this would exist for both children as well as adolescents. In terms of linear speed development, we have some research from 2009 that found age uniformly affected running speed during each 10-meter section of a 30-meter sprint. So they found that there was a significant development of speed that was evident about every 2 to 3 years, indicating that a growth and maturation effect to speed. While boys performed on average better than girls, this differential actually increased after the age of 15. Additionally, speed increases appear to reach a plateau, and this occurred at the age of 15 for boys and between 12 and 13 for girls. In relation to strength development, speed is improved earlier than strength, with approximately 75% of the performance achieved at age 18 visible at age 12, whereas strength is typically 40 to 50%. So this supports the idea that scores in motor performance, in the absence of training interventions, appear to plateau at the end of peak height velocity. However, though, it's important to note this does not indicate that continued improvements in performance through effective training interventions are not possible beyond this plateau. And it's also important to note that young athletes who have missed out on training during these phases will not necessarily always be at a disadvantage. Instead, it merely suggests that maximal natural development of speed capacity through natural growth and maturation has already occurred, and that appropriate training interventions will be needed to enhance any sort of speed performance. And given the data that's out there, data really kind of suggests that agility would be trainable in pre-adolescent as well as adolescent athletes. And here's just a quick shot of the research that showed the effect of chronological age and gender on the development of sprint performance during childhood and puberty, done by several researchers back in 2009. And you can see here, based on the data, age uniformly affected their running speed in each 10-meter section of a 30-meter sprint. You can see a significant development of speed every 2 to 3 years, which shows us that growth and maturation effect. As far as differences between the genders, you can see that boys performed better than girls, and you can see the difference, that gender difference that are increased starting after the age of 15. What this information also shows us is that speed increases appear to reach that plateau, and it occurs again after the age of 15 for the boys, as well as 12 to 13 for the girls. So this is where I think it kind of gets interesting, because we start to really focus on the development of the athlete in a sport, not necessarily just in regards to agility, but now we're considering how the maturation of the human brain impacts the ability for an athlete to be bigger, better, faster, stronger, and more agile. A lot of studies that we've seen give us an idea of the brain function and brain developments in order to kind of give us this insight into the value that agility development may play with our youth populations. So we look at agility performance and how it requires the development of effective and consistent motor programs. And we understand that movement is controlled via the central nervous system. So the brain plays an important role in agility, from the perception of the stimulus to the cognitive ability to select the appropriate information, and then the subsequent selection and application of an appropriate motor program. Prepubescence has been identified as a period in which rapid development of the neuromuscular system occurs. And preadolescents have considerable potential for motor learning, with the prime window of opportunity prior to puberty. This would fit in with the fact that around the ages of 11 to 12, prepubescents go through a growth spurt in synaptic elaboration. Sorry, I talked a little fast. So synaptic elaboration is a process that starts in the rear of the brain, and then it moves to the middle, and finally to the prefrontal cortex. This particular sequence of synaptic elaboration has important implications for agility learning, because the rear part of the brain is responsible for processing sensory information. It's also involved in dealing with the perceptive information required for effective agility performance. The middle section of the brain is the part that coordinates movement, and so it's responsible for the development of effective motor programs. And then finally, the prefrontal cortex is responsible for the decision making and the planning, and it's ultimately responsible for making effective movement-based decisions, especially in sports contexts. And while there is little direct data to support the concept of a prime window of opportunity, it definitely seems logical that agility development would play an important role in the training of an athlete through the prepubescent period, developing the motor programs along with any sort of perceptive and cognitive capacities that would underpin or support performance in other phases of training. It should also maximize the natural development of the brain by involving sensory information from the start, and then progressively developing efficient and effective motor programs and effective task-based, as well as any sort of decision-making capabilities. Studies that really kind of outline the way the human brain functions can therefore give us an insight into the value of open drills to agility development for both inexperienced or developing athletes as well as advanced athletes. Because in order to perform well in sports, the brain has to develop optimal synaptic linkages that directly connect the areas responsible for the decision-making process with those involved in optimizing the physical responses. So as coaches and as trainers, we want to increase cognitive challenge in our drills, in our training, in our programs for our athletes, to ensure that there's going to be a continuation of learning and that learning is also maximized. But there's an appropriate progression of introducing these cognitive challenges. So when we talk about introducing a cognitive challenging task, both areas, number one, of the brain are active and they effectively develop these synaptic linkages. So let's talk about the early stages of development as well as later stages of development. When we talk about a young athlete who is beginning to develop in the sport, these synaptic linkages, the formation needs to be encouraged, but due to the delayed development of the prefrontal cortex, a young athlete's decision-making capacities will be limited. So what that means is that during training, exercises need to be utilized that limit the amount of information that's taken in and also limit the movement patterns and the options required. So we do increase a cognitive challenge, but we are very careful not to overwhelm an athlete immediately with lots of different information that requires lots of different decisions to be made. However, as a young athlete develops, we can increase the information that's provided according to the task, as well as increase the number of movement options given. And this is how we progressively develop these key synaptic links. I'm going to say links, not linkages, because apparently I have a hard time saying that word. It's important to note, though, for coaches and trainers, if exercises are not progressed, or they remain predominantly closed in nature, an athlete will only be able to perform these certain tasks with less and less cognitive involvement. This has potential downsides to learning and performance because once automation is achieved, the higher centers of the brain aren't stimulated and the centers for automacy take over. And the centers for automacy are able to perform well in predictable environments, but they're unable, and here's where it gets important, they're unable to detect new cues and unable to adapt to unpredictable environments. So this makes movement patterns that are developed in closed environments at risk of breaking down when an athlete experiences unusual or new or stressful situations. So again, the bottom line in regards to this kind of sort of cognitive training for an athlete is that as a young athlete progresses, there needs to be an increased cognitive challenge associated with the sport tasks or the sport drills in order to ensure that learning continues and it is ultimately maximized. And here's the slide that outlines that last bit that I just mentioned that wasn't on the previous slide. Okay, moving forward then. Let's talk about practical applications in regards to agility development and increasing cognitive tasks or the cognitive learning that's associated with improving an athlete's ability to be agile. What we've seen is that effective skill development is usually based on an appropriate sequence of development, just as individuals learn skills in progressions. So very similar to a classroom or an educational setting, there's some sort of sequential syllabus that can be developed where movement abilities can be sequentially developed in order to maximize some sort of game performance. So on the next slide, you're going to see this agility pyramid, a sequential agility pyramid. And this is based upon the concept that movement patterns should be introduced and then sequentially progress through stages until an athlete is capable of applying movements in a sport-specific setting. And it looks like this. And what you can see here is the foundation of this agility development pyramid is kind of in coordination with the cognitive stages of learning development, where we understand, where we want the athletes to understand the nature as well as the goal of the activity or the skill to be learned. We will also see initial attempts at these particular skills to be fraught with gross errors. And so the aim in this particular stage is to allow the athlete to be exposed to a bunch of different movements, but then to allow them to develop a full range of movement capacities, but also to introduce the perceptive skills that's required for optimal performance. So again, we'll see movement competency at this stage to be relatively low, but the aim is to draw the young athlete's attention to, number one, the rules of the movement, and to aid in the development of some of the cognitive skills required of advanced performance. And at this stage, again, the quality of the patterns really should take precedence over the speed of the pattern itself. Next, The development phase usually occurs for an athlete between the ages of 12 and to 15. A lot of times, young athletes will have successfully completed the previous stage, and when they move into the development phase, then they're likely to enter the associative stage of learning. The aim of this particular phase is to master general movement patterns and develop those patterns in relation to key movement combinations, as well as some general sporting tasks. Movement combinations will involve the deployment of a series of movement patterns that are typically seen in sport. With this particular phase, there's going to be a far greater emphasis placed on open drills, and this means that the athlete will then be required to respond to increasing movement challenges, and that the movement tasks themselves will become increasingly sport-specific more as the stage progresses. And what this does then is increase the cognitive effort that's required, and it also helps develop and reinforce those synaptic links that are required for optimal performance. Towards the end of the stage, athletes are likely to start specializing in one or two sports, and so this is when the coach can utilize exercises that become more sport-specific and more task-based in terms of challenges for the specific sport. One thing I do want to mention about the developmental phase of the agility development period is that this particular stage normally includes the onset of peak height velocity. And if you remember about adolescent awkwardness, an athlete's coordination is going to be significantly challenged during this period when they are learning to cope with their rapid increase in body dimensions. So the progression of skill development within this phase is very much nonlinear in nature, and the coach might even need to regress a certain drill or drill complexity in order to enable an appropriate level of stimulus to the athlete that's undergoing this growth spurt and maybe this kind of physically challenging point of their development. The final level of the agility development pyramid then is the performance phase. And at this point, the athlete will have participated in a significant amount of training. Their movement patterns should show consistency and they should show effective movement. So during this stage, an athlete, it's very possible that they've reached this autonomous level of skill development. And so here their movement patterns are very highly automated. And so that means that a greater degree of challenge is needed in order to provide a sufficient stimulus as well as cognitive challenge in order to ensure gains or further gains in agility performance. Also, athletes at this stage are likely to be specializing in a certain sport, the use of context-specific tasks, utilizing a high degree of context specificity, and a high number of degrees of freedom are ideal in order to continuously challenge the athlete and their growth and development in the particular sport. So what I've done for the next couple slides is I have basically put my words into the PowerPoint itself. So I've already discussed all this, but I will post this particular PowerPoint so that you can take time to go back to it. What I am going to get us up to are some useful tools. Here we go. Tables. I like to provide graphics along with lectures. So this is a table that goes along with the bottom portion of the agility development pyramid. So this is about the foundation level for an agility session. So you can see here some coaching guidelines that would be helpful to any sort of coach that would like to utilize agility training within their specific sport. So you can see some guidelines here in relation to things like develop key movements of the sport, really focusing on that movement quality over any sort of movement speed, asking athletes to really perform single task skills instead of multitask, making sure that as a coach you have your quality instruction. In other words, emphasize or maybe pre-plan what you're going to say ahead of time, and so that your wording is limited but it's concise and to the point, so the athlete knows what the task requires, with you omitting any sort of long extended explanation as to why maybe they would need to be able to perform the skill. So quality instruction using all three communication preferences. So that is referring to things like try and explain your directions for the visual learner, try to explain your directions for the auditory learner, try to explain your directions for the kinesthetic learner that needs to see it in motion. And it goes on to talking about things like at the bottom of the list where we have minimizing fatigue, and then make sure you're giving them specific feedback and keep it precise. And so then it goes into the development phase. Again, we've already kind of discussed this. So again, if you'd like to revisit this, you can with the PowerPoint, but I do want to speed you forward to the chart again, the coaching guidelines. So this is considered a dynamical systems approach from Holmberg, who put this out in 2009. This table can be used in conjunction with the development phase of Agility Pyramid, and you can see some training progressions in order to give the coach kind of a better idea of some practical applications for selection of drills during some sort of practice. So you can see suggestions for technical training versus pattern running, reactive agility training, as well as drills that would be useful in terms of change of direction. And here are some coaching guidelines as well for the developmental level. So talking about forcing your athletes to look at key transitions and movement patterns of the target skills that you want the athlete to perform. First, utilize those closed drills and then gradually move to more open drills where there's more information to interpret and to process in order to produce the movement. We can also increase the speed, the technicality, as well as the variety of the drills. Reducing the quantity of feedback to allow the athlete to actually think and to maybe self-monitor and maybe self-correct in terms of the skills that are required, which kind of leads us to the next bullet of challenging athletes to really monitor their performance and to verify, am I doing the right thing? What do I need to change about what I'm doing? And here's our coaching guidelines for athletes who reach the top of that agility performance pyramid. So it kind of gets a little less complicated, I guess, in terms of guidelines, because really what's happening at this point is you typically have athletes that have been specialized, so they're there, they're committed, they're dedicated, they've probably been in this sport for a while now. They have a foundation, they're able to exhibit the appropriate movements that are required. And so this is when you need to really focus as a coach on providing a variety of those complex open drills that are very sport specific, that are in the target context. You're going to keep the athletes guessing, right? So there's going to be quite a bit of variance to cognitively challenge the athlete. Feedback should be there, but it should be very infrequent, but it also should be very precise in nature. So pinpoint exactly what that athlete is doing correctly, and make sure you verbalize that with your athletes. A simple good job or a pat on the back isn't really going to fully illustrate to the athlete what you want them to repeat again. So specific praise is important, but keep it limited. And that also should help the athlete answer any sort of movement related questions they may have in order to alter what they're doing to improve upon it for next time. For those groups that are still building their sports presentations or sports group presentations, I really encourage you to look at the back of Chapter 8, because it talks a little bit more in depth too about this, what movements need to be developed, In other words, so how do you break down agility into component parts? It also gives you kind of a glimpse into that agility syllabus, so focusing on target movements versus target mechanics, and then modulating the challenge of agility drills. So how do you keep a young athlete challenged? And the back of the chapter also presents a very nice table that illustrates target movements and target mechanics, from the initiation of introducing these agility drills all the way through actualization, where you're really then beginning to focus on things like acceleration and speed during a specific task. So just a couple key points. I want to end our lecture kind of discussing this complex, or this context, that agility is a highly context-specific capability, and it supports the performance of a lot of sports skills. And in constructing an effective agility development program, keep in mind the following points. First of all, agility is a key performance in many sports, and it should be a vital component of training of all young athletes. We also know that agility performance is affected by the organismic, task, and environmental constraints. Agility development is optimized through a sequential model of development that's based on physiological as well as cognitive development of the young athlete. We've seen target classifications that allow component parts of effective agility to be identified and then sequentially developed. And finally, the use of degrees of freedom really allows agility challenges to be progressively enhanced to increase cognitive challenges to the young athletes. And that is the conclusion of our lecture in regards to agility development in youth populations.